Hello everyone and welcome to this lecture in the hands-on large language models series. Today we are going to learn about a very important topic, and that topic is related to controlling the outputs of large language models. So we have been discussing a lot about prompt engineering, basic and advanced prompt engineering, and how to get the responses which we desire through interactions with ChatGPT and through interactions with large language models. What we have learned so far is that a good prompt leads to much better answers, and there are a huge number of techniques which we demonstrated to you to write good prompts. Techniques such as chain of thought prompting, tree of thought prompting, chaining different prompts together, in context learning, few shot prompting, one shot prompting. There are so many techniques which we learned. Today, we are coming to this lecture from the perspective of safety. That is one. And also from the perspective of format of the output itself. So, what if large language models give an output which is not safe? What if large language models provide an output which is harmful or contain abusive language? How can we prevent large language models from producing outputs which are not safe, which we don't at all endorse or which we don't at all require? That's number one. And the number two, which is the second point we are going to see today, is what about the formatting itself? If we want the answers to be in a specific format, what if ChatGPT or large language models are not adhering to that format? How can we control the model output to what we exactly want? What are the reasons for validating the output of large language models? There are four reasons which we are going to discuss. The first is a kind of structure in the output itself. So, by default, most generative models create free form text without adhering to specific structures other than those defined by natural language. Some use cases, such as in coding or in other places, require their output to be structured in a certain format. Like JSON can be one type of format. There can be other types of formats, such as, let's say, CSV. If you're writing a LaTeX document, it needs to be .text format. So we need outputs to follow a certain structure in all of these examples where we need the output to be in, let's say, JSON, CSV or .text. That is one reason for validating the output. The second reason is that even if we allow the model to generate structured output, it still has the capability to freely generate its content, right? So let's say even if we say that generate this thing in JSON or generate a .text file for me, the LLM is still free to choose what it wants to generate, because after all it's a probabilistic model. So for instance, when a model is asked to output either one of two choices, it should not come up with a third choice. So this is one common example. Let's say if you ask the model that classify the movie review into either positive or negative, it should not come up with a third option which is neutral. How do we really make sure that large language models don't give such outputs? Then the third thing which is extremely important is ethics. This is probably one of the most important applications of today's lecture. So some open source generative models have no guardrails, which means that they will generate outputs that do not consider safety or ethical considerations. If you're running toy projects or if you're just running student projects, maybe you might not be thinking about these things. But if you're part of a big industry or if you're a startup which affects the lives of millions of people, ethics plays a very, very important role. You really don't want your generative model to output language which is abusive, to output language which consists of personally identifiable information. This can be a huge security threat. If a large language model freely describes personal information about anyone, that's a security risk, right? Then we don't want the model to endorse cultural stereotype, have bias, or be racist. We need to prevent racist responses from the model. We need to prevent biased responses from the model. We need to prevent abusive language generated by the model. And we also want to prevent private information such as personally identifiable information to be generated as the model output. So one of the major reasons for validating output is that we need to follow good AI ethics. And we are going to see some ways in which we can do this today. And the last thing is accuracy. So many use cases require the output to adhere to certain standards or performance. If you have released an application to clients, and if these clients are big industries or industries which operate in quick, fast moving environments, you cannot have large language models which hallucinate or provide information which is factually incorrect. The aim is to double check whether the generated information is actually factually correct or not. So that's why validation of output is really essential. If the LLM provides an output, we need to go back and validate it once more to check that it's actually accurate, it is coherent, and it is free from hallucination. Just as a quick reminder, we are following this lecture based on this particular book called Hands-on Large Language Model. And I just want to take a moment to show this great book which is written by J. Alamar and Martin. So here you can see this book is available, and most of the examples which I'm taking in this lecture are based on this book. So thanks to the authors for releasing this book, and I've learned a lot from it. Alright, so now we learnt about the reasons for validating the output, right? Now let's look at some methods through which we can validate the output. So in particular, there are three ways to control the output of a generative model. Let me mark them with a different color. So there are three ways to control the output of generative model. Some of these ways we have already seen before. For example, the first way is to provide examples. Remember, we learnt about this in few short learning. So if we want the large language models or generative models to provide or to produce a certain output, we need to just provide a number of examples of the expected output. And that will make sure that the LLM really does a great job at following the output structure which we want. The second thing what we can do is that we can control the token selection process itself. So instead of selecting the tokens in a probabilistic manner, we can include some kind of a deterministic, we can include some kind of determinism in the token selection process itself, so that random tokens are not generated in the next token prediction task. And finally, we can do some fine tuning, so that what we can do is that when we use pre-trained large language models, we can add an additional layer of fine tuning on top of it, and we can fine tune the model on data which contains the expected output. So this is like we are teaching the model that, hey, I know you're trained on huge amount of data, but for this particular use case, I expect you to train on this other smaller data and check the format which I have mentioned in this data, because I want you to follow this format. So then this tuning means that we need to retrain the model. We need to retrain the model on smaller specific data. We need to retrain the model on smaller specific data which follows the format which we require. So these are the three broad level techniques which are the ways to control the output of a generative model. Let's look at the first example, which is the easiest, as we have explored this before. So one of the easiest ways to get a model response to be the kind of response you want is to provide some examples when you provide the prompt. So for example, let's say if you're playing a game, right? And if you want to create a character profile, but if you want to create it in a specific format, which is a JSON format, if you are not aware of what the JSON format looks like, let me show you how a JSON format actually looks like. So what is it? So it's a text-based format for storing and exchanging data, and it looks something like this. See, this is an example of a JSON format. For now, just remember that it's a particular type of format, and it's very useful for different forms of coding purposes, for front-end, back-end, website development, etc. So let's say that there is this task where you want to create a character profile, but you want to do it in JSON format. The one way to do it is provide no examples. And here you see the output. Here is the character profile which is created, but this is not a valid JSON over here because there are no closing brackets, right? If you looked at the JSON format over here, you would have seen that there are closing brackets. But if you look at the format which is generated here, there are no closing brackets like how I have drawn here. These closing brackets are not present. So this is not valid JSON format. To fix this, what we can do is actually we can just provide an example, right? So what we can do is that we can provide an example of what we want the output to be. So the prompt text stays the same. Create a short character profile for an RPG game. Make sure to only use this format. So now see here, we are providing the format, which means that we are providing an example of what we want the character profile to look like. So this is a JSON format which we have provided in the prompt itself. And now the LLM or ChatGPT knows that it has to follow this structure because it's been mentioned in the prompt, right? So when it generates the output, you can see that this is the output which has been generated, and this is perfectly valid JSON because here there is a starting bracket, curly bracket, there is an ending curly bracket, etc. So then this on the right hand side is a valid JSON format. On the left hand side, what you have is a JSON format which is not valid. And what made this difference from left to right? Only providing certain examples in the prompt. And I even show this in the code file. So I'm going to share this code file with all of you when I'm going to share this lecture. And we have explored all of this in the previous classes. The section which we are going to explore today is output verification. So here you can see that first we have given a zero shot prompt, which means we have given no example, and we have asked the LLM to provide the response. Just to recap your understanding, the large language model which we are using in this notebook is Microsoft Phi 3 Mini 4K Instruct. It's about 3.8 billion parameters, I think. So it's a small model to start with. Right, so this is the prompt, and if you print out the output here, you will see that this is the output, which is not a valid JSON format as we discussed on the whiteboard because there is no closing curly bracket over here. Now I'm changing the output a bit here. See, I am saying create a short character profile for an RPG game. Make sure to only use this format. And I actually explicitly provide the format here, which means I explicitly provide the example. And then I say that generate the text based on this template where I have provided the example. And now you see the character profile has been created in a JSON format, which means that there is a starting bracket and then there is a closing bracket also. This is a very valid JSON format. So if you run this code file, which I'll share with you, you can run first the zero shot prompt and you will see that the format is not valid JSON, and then you can run the one shot example, and here you will see that this is indeed a valid JSON format. The place where you will find these examples is in this section called as output verification. Alright, so that's the first way to control the model output, that's providing examples. The second way to control the model output is constrain sampling. So what this actually means is that in few shot learning, we cannot explicitly prevent certain output from being generated, which means that even if we provide certain example, we still cannot guarantee what tokens will be produced. In constraint sampling, what is actually done is that we can take some steps in order to actually prevent certain output from being generated. So what I'm going to show is just a schematic for this, which is the schematic of constraint sampling. So let's say the prompt is classify this sentence into positive, negative or neutral. What a great movie. Zero shot prompting is just we directly ask this to ChatGPT and it may give some answer. There is a great chance that it will write a full sentence instead of just saying positive, neutral or negative. So that's not good. So let me write the possible options here. The first option is zero shot. That's not very good. The second option is few shot, where we actually give an example of a movie and classify it as positive. So that is much better, but still it's a probabilistic process. So how can we be sure that every time ChatGPT produces either positive, negative or neutral? The third option is what we can do is that when we let's say these are the possible tokens of the next token, right? What we can say in the code is that in the code itself we can write that when you look at these tokens, only choose the tokens belonging to positive, neutral or negative, compare the probabilities of these, and then choose the token with the highest probability. You see what this has done? What this has done is that in the few shot or zero shot, we still had all of these tokens, right? And the token which has the highest probability would be chosen. But now with constraint sampling, what we have done is that we in the tokens itself we have said that among all of the next options, only look at positive, neutral and negative tokens and then choose the token with the highest probability. So now we are completely sure that the answer is either going to be positive, negative or neutral. And in this case, positive seems to have a higher probability. So this will be the answer. So this is the ultimate check. Constraint sampling is we can completely control what we want the output to be. So we'll 100% be sure that it will either generate from positive, negative or neutral, because we would provide this in the code itself that as the next token, don't generate any other new token. Just look at three tokens, positive, neutral or negative, and then choose the next token with the highest probability. That is actually called as constraint sampling. Another technique here is that we can fill some parts of the output ourselves, or other way to tell this is that when we write the prompt, we can give the response template. We can give the response template in the prompt itself. So for example, let's say if the expected format is this kind of a JSON format, right? What we can do is that we want the highlighted text to be produced here, but this other format we can provide ourselves to the large language model. So what we can do is that this kind of a format, we can say that we need this format: ID, height, name and age. We can tell in the prompt itself that I need this particular format, and then we can ask the LLM to fill the particular value. So it will fill something for ID, it will fill something for height, it will fill something for name, and it will fill something for age. This will also make sure that we get the correct output, because we'll use the LLM to generate only the pieces of information which we do not know beforehand. We know the formatting beforehand, what we expect, right? So we can put that in the prompt itself, that this is the format I expect, and mention the format, and then only ask the LLM to fill the missing pieces. That's it. So LLM will only generate the missing pieces and then we'll complete the output by ourselves. This will make sure that instead of providing random output, we ourselves fill some part of the puzzle and then ask the LLM to fill the remaining part. And I have mentioned this in the code also. So in the code, the first example is providing examples, the first code which we just saw. The second code which we are going to see is we are going to use this, we are going to use a Phi3 model again, but we are going to use a quantized version of the Phi3 model, which just reduces the memory capacity, which is taken from our PC, right? And then what we are going to do is that here you see we are going to use this prompt that create a warrior for an RPG in JSON format like we saw before, but now we can provide the response format, which is the JSON object. So here you see we have mentioned that this is the response format which I need, which means that the format itself we have specified in the prompt, and that makes the task easier for the large language model because it knows the format. So here you see this is not few shot, because we are not giving another example over here. We are just providing what we want the response format to be. That's it. And then here you see the response has been generated, and this is very valid JSON response. It's a long response, so but if you see the response from the start, it starts with a curly bracket and then it goes till the end, and at the end there is a closing curly bracket. So this is a very valid JSON response. If we just use zero shot without giving the response format, ChatGPT or the LLM will make a mistake. It will not provide the output in the format we need. Now the only reason it has provided the output in the JSON format is because we have mentioned here that the response format which I need is JSON, and that's why it has made no error, right? So it's like here we are completing some parts of the puzzle for the large language model, which means we ourselves have given the response type and ask it to fill the parts which we don't know. So these parts, these texts and everything else we did not know, that is filled by the large language model. So these are some techniques which you can use. The first technique which we saw is providing examples, of course. The second technique which we saw is sample only selected tokens. And the third technique which we saw is fill some parts of the output ourselves. The fourth and the last technique which we are going to see right now is that look at this pipeline of large language model which I have given over here. Let's say we give a prompt to the large language model and it provides an answer over here. Now what we do is that instead of this answer directly being the output, we add another step in the middle, and that step is called as the validation step. So this is also called as the validation layer. So instead of directly passing the answer as the output, we add another layer here which is called as the validation layer. What this validation layer does is that it checks the output and checks the format of the output, right? It checks the format of the output, and if the format is correct, only then the output is produced. Otherwise, there is an error. And so this green validation layer which I have shown, that also is a large language model itself. So this validation layer is also a large language model which takes the output which has been produced previously and it checks the format of this output. And only if the format is correct, then the output is printed. Otherwise, there is an error. So here the main idea is to use an LLM to check whether the output correctly follows our rules or not. So there are two LLMs being used here. See, one LLM is used for generating the output and another large language model is used to validate the output. And if the validation is correct, only then we proceed next. So now what I'm going to do is that I'm going to show you some commercial applications. I'm going to show you 4 applications which have been released. They are all open source. They are on GitHub. You can start using them right now. They are released to provide safeguards, or they are released to validate the output of large language models so that it does not provide any random output. So this will be, you can directly go to these repositories which I'm going to show you right now. You might be knowing some of them, but some of them will be new to you. So it will be very valuable piece of information for you. Alright, so let's go to see the applications right now. The first GitHub repository which I want to show you is called guidance-ai/guidance. And what this repository does is that it basically selects what type of response you want. So let's say if we want the large language model, or this is the prompt that do you want a joke or a poem, but here we can specify this. So here we can say select between a joke or a poem. So then the generation will be constrained. So then the large language model will either say joke or either it will say poem. It will not say anything else. So here you see, do you want a joke or a poem, and then the output is a poem. So here the model generates options which we want, and that is not an easy thing to do because it's a probabilistic process, and that's why this repository is so valuable. Because if you want the output to be constrained, if you want the output only to be among a set of options, so here if you want the output to be only between, let's say, joke or poem, what you can do is that you can say that you can use this select command over here, which selects between either a joke or a poem. So this is the main advantage of this repository here, which is called guidance. And if you see the number of stars on this repository, you will see that it has 20,000 stars, and it's a guidance language for controlling the output of large language models, right? So it basically guides and steers large language models in a direction which you want. I'm not going into the details of this, but I just showed you one simple tool in this package which you can use. I'll probably make a separate video to show you exactly how to use this package. But right now I just want to give you a brief overview of the different type of packages which exist to constrain the large language model output. Then another package is called guardrails-ai/guardrails. So it's a bit different than this. This guidance dash AI, that's the main organization, and guidance is the name of the repo. Here the name of the main organization is Guardrails dash AI, and the name of the repository is Guardrails. So what Guardrails does is this kind of a validation which we saw earlier. So what Guardrails does is that, let's say without Guardrails, we just have a prompt which goes into an LLM and then there is an output. What Guardrails does is that it checks two things. It checks whether the input follows a certain constraint, and it checks whether the output follows certain constraints. And the constraints can be mentioned by the user themselves. So here, for example, in this schematic, the output is going to check whether there are any hallucinations. The output is going to check whether there is any profanity or abusive language, or if there is a mention of competitors. If any of these things are mentioned in the output is going to get flagged and then it won't be produced. Similarly, in the input itself, if the input consists of personal identifiable information or PII, or if the input is off topic, or if the input is an attempt to jailbreak, which means the input is an attempt to confuse ChatGPT or to manipulate the LLM, there will be flags which will be raised and the output won't be produced. That's why it's called guardrails. The output will only be produced if all of these guards are satisfied. It's like if a guard is satisfied, they'll let you through, right? If the input guard is satisfied and if the output guard is satisfied, only then will the output of the large language model will be good, and then the output will be produced. The way this works is that you can just get started with it right now. You can do pip install guardrails AI, and then you can do different things. So for example, here there are two things: competitor check and toxic language, which means that if the output has an information about competitors, it will be flagged. If the output has toxic language, it will be flagged. So you can mention the competitors here, let's say Apple, Microsoft, Google, and you can mention the threshold for the toxic language. So if the output is shut the hell up, Apple just released a new phone. This is a toxic language, right? So there will be flags which will be raised first for the toxic language, and second flag will be raised for the competitor mention. So the output won't be produced here. So here you see validation failed for the field with errors. Found the following competitors Apple. Please avoid naming these competitors the next time. And also the following sentences in your response were found to be toxic. And the sentence here which was found to be toxic is shut the hell up. Isn't that awesome? The output will not be produced, but it also gives you error messages of why the output is not produced. You can start using this right from now. And there is also this Guardrails hub. So what's present in the Guardrails hub is the different kind of constraining which you can do. So competitor check is something which we saw right now. You can even check gibberish text, which is random text. You can restrict the output to a particular topic. You can restrict the output to be CSV. We saw the JSON format, right? With this kind of an application, you can even restrict the output to be a valid JSON, or you can restrict the output to be valid SQL. There are a huge number of guardrails which you can see over here. There are 62 validators, and you can start using this right from now. This application falls under this particular figure where we use another large language model to validate the output of the first large language model. So here also you'll see that the number of stars to these repositories is around 4000 stars. So these two, and then another one is called LMQL. Basically what this is, it's a programming language for large language models. So here what you can basically do is that you can use the where keyword to specify constraints and data types of the generated text. So this LMQL is also quite popular. You will see it has 3.7k stars, and it's a programming language for large language models. So basically, if you see just how you write code, you can write normal code to interact with large language models. So you can think of LMQL as a programming language itself. So here you can say this is a test, and then here is the response. So this will be the response from the large language model. Now, if you are using this programming language, within the programming language itself, there are some things such as the where keyword, which you can use to specify the constraints which you want, and if you want the output to be of a particular format, etc. Right. So there are three GitHub libraries which I just showed you right now, all of them are open source and all of them are extremely useful. The first is guidance, which basically you can use right from now, and you can use this select feature to select the select command to constrain the generation of the output to your the output which you need. There are several other things here which I did not go into right now because this is not a video about explaining applications in detail, but you can start using this from today. The second is Guardrails, which is an awesome tool and it has a huge number of validators which you can use to constrain the output. So this schematic explains guardrail pretty well. There is an input guard and output guard, and you have to mention what kind of guards you want. And only when they are satisfied, the output will be validated and it will be produced. Otherwise, there will be errors which will be printed out, and as you can see here, the error will be printed out and the output will be flagged. And the third repository which I showed you is actually a new programming language itself for large language models, specifically for large language models, and that gives you a lot of flexibility. Since it's a new programming language itself, you can use different keywords in this language to constrain the output to whatever you want. Using these three GitHub repositories, you can already start practically implementing the theoretical lessons which we learned in today's lecture. This brings us to the end of today's lecture, but I again want to highlight this, that using prompts and getting good responses is not enough. You also need guardrails. You need guidelines in place or validators in place to make sure the output is exactly what you want. And that's especially true if your product is going to have an impact on a huge number of people. You cannot have the large language model producing random stuff which is not ethical. You can use all of the tools and techniques which we discussed today to make sure that the output is validated, and the output should be flagged if it's not correct, and it should not be displayed to the user. Thanks everyone. I hope you are liking this approach of hands-on lectures on the whiteboard plus the hands-on coding session which we are doing. I'll share this entire code file with all of you. But please keep in mind, when someone says prompt engineering, technique is important, but validating the output is equally important. Validating or controlling the output. Thanks everyone, and I look forward to seeing you in the next lecture.